In the early 1980s, while the world was embracing personal computers, two brilliant minds were quietly laying the groundwork for something even more transformative, a revolution that would reshape how machines think and learn. Today, John Hopfield, age 91, and Geoffrey Hinton, 76, have been awarded the 2024 Nobel Prize in Physics for their groundbreaking contributions to artificial intelligence. Meet John Hopfield, a physicist from Princeton University who posed a question that seemed almost ridiculous at the time: what if the brain worked like a magnet? Hopfield was inspired by the physics of magnets, where magnetic spins, tiny forces within atoms, align to create stability. In 1982, he proposed the Hopfield network, a model where neurons in the brain behave similarly to these magnetic spins, aligning to find stable solutions. In the same way that magnets align to minimize their energy, Hopfield's network searches for the most stable solution by minimizing energy in a similar fashion. Each neuron can be thought of as a tiny magnet that adjusts itself based on its neighbors, working to form a coherent pattern. This network could take incomplete information, like a distorted image, and fill in the missing parts, just like your brain does when you see part of a friend's face and mentally reconstruct the rest. It was a profound insight into how machines could simulate human memory and reasoning. At the same time, Geoffrey Hinton, a cognitive psychologist with a fascination for how the human brain learns, was about to make his own groundbreaking discovery. Hinton turned to the Boltzmann equation, a formula from thermodynamics that describes how particles move in gases. In 1985, Hinton applied this concept to neural networks, creating the Boltzmann machine. Just as gas particles move to find their lowest energy state, Hinton's network adjusted itself to find the best possible solution for learning patterns in data. The Boltzmann machine introduced hidden units, nodes that aren't directly connected to inputs or outputs, but allow the network to learn complex internal representations of data. This was a huge leap forward, allowing machines to discover hidden patterns, similar to how our brains form abstract concepts. One of Hinton's key innovations was applying a technique called simulated annealing, a process used in metallurgy to cool materials slowly and remove imperfections. In AI, this meant allowing the network to explore different possibilities, adjusting until it found the most efficient way to represent the data. So how does all of this work in practice? Think of it like teaching a child to recognize cats. At first you show them lots of pictures, some with cats and some without. Over time they learn to identify the key features: whiskers, ears, and fur. AI works in much the same way. The more data it processes, the better it gets at recognizing patterns. Hopfield and Hinton's work didn't just stop at theory. Their contributions laid the foundation for deep learning, the technology behind the AI systems we use today. Their ideas power everything from the voice assistant on your phone to the algorithms behind self-driving cars. The ability of machines to learn and recognize complex patterns directly traces back to Hopfield's associative memory model and Hinton's work on hidden layers. But the impact of their discoveries reaches far beyond just technology. AI systems inspired by their work are helping scientists solve some of the world's toughest problems. At CERN, AI is helping sift through massive amounts of particle collision data, searching for new particles that could fundamentally change our understanding of the universe. In climate science, AI models based on these principles are improving the accuracy of extreme weather predictions, helping save lives and resources by preparing for natural disasters. Today, at ages 91 and 76, John Hopfield and Geoffrey Hinton are being honored with the 2024 Nobel Prize in Physics for their pioneering contributions to AI. Hopfield's associative memory networks and Hinton's Boltzmann machine and backpropagation have forever changed how machines learn and think. Their story is a testament to the power of connecting ideas across fields, from physics to neuroscience and beyond. The breakthroughs of tomorrow could come from any combination of disciplines. Who knows? Maybe the next revolution in science and technology will come from you.